Welcome to my algebra class. We're on chapter 11 on the section on fractional exponents. If we have a fractional exponent, such as a equals 1 over n, the n stands for the root of that particular number, and the 1 is the power. So if I have a to the 1/3 power, what I'm looking for is the cube root of a. For example, 27 to the 1/3 power would be 27, cube root of 27, what number times itself 3 times equals 27, and that would be 3. This would be the 4th root of 16, what number times itself 4 times equals 16, that's 2. And this is the 5th root of 32, what number times itself 5 times equals 32, that would be 2. There is a key on your calculator. Let's see if I can pull it up here. It's on this one. And it's if I want the cube root, let's try 16 to the 1/4. So if I put in 16th, back that up. Let's clear it. 16 to the equals 2. So I put in 16, which is my base, and my root is 4. We can try another one. Let's clear that out. 27 to the 3rd root. So 27, hit this key and give the root, which is 3, and it should come out 3. So you can use that key also to help you. If I try to take the square root of a negative number, there is no real answer because there's no number times itself that equals a negative value. So if you have a negative times a negative, you're going to get positive. If you have a positive times a positive, you're going to get positive. However, you can take an odd root, such as 1/3. So if I want the cube root of negative 27, it's going to come out negative 3, because negative 3 times negative 3 is positive 9 times the negative 3 is negative 27. And we can show that. If I put negative 27 and get the cube root of that, it comes out, well, it should come out negative 3. It didn't. I used the wrong sign. Okay, let's try it again. 27 cube root 3. Well, just doesn't say anything. Anyway, it does work. And then if you have a fractional power where the numerator is not 1, the n is the root, the denominator is your root, and the top number is the power. So if I have 8 to the 2/3 power, that's the cube root of 8 taken to the 2nd power, and the cube root of 8 is 2, and 2 to the 2nd power is 4. And the second example, the 16 to the 5/2 powers, that's the square root of 16, which I don't put the 2 in for the square root, and taken to the 5th power. The square root of 16 is 4, and 4 to the 5th power is 1024. So reviewing again, you can't take the even root of a negative number. You can take an odd root of a negative number. And if you have a fractional exponent, the numerator is always the power, and the denominator is always the root. So we're ready to do the evens. Open your book to 553, and we're doing exercises 1 to 34. So number 2. Write each of the following radicals in exponential form. So the square root of 10 is 10. There's no power, so it's 1. And radical without a number here is 1/2. So it's 10 to the 1/2 power. Number 4, the seventh root of 5. There's no power, nothing's being taken there, so it's 5 to the 1/7 power. Number 6, the fifth root of 3 is 3 to the 1/5 power. Remember, the bottom number is the root. Number 8, we have the fourth root of 14, which is 14 to the 1/4 power. Number 10, we have the fifth root of -12. Since it's a negative and it's an odd exponent, or an odd root rather, then we can take its root to the 5th power, so it's -12 to the 1/5. Number 12, we have the sixth root of 8 taken to the 5th power. So that's 8 to the 5/6 power. Remember, the power is the numerator, the bottom number is the root. Number 14, we have the square root of 7 taken to the 5th power. So it's 7 to the 5/2 power. The root is the square root, which is 2. And 16, we have the square root, the 7th root of 5 taken to the 3rd power. So that's 5 to the 3/7 power. In the second set of problems, 17 through 34, if the expression, you are to simplify, if the expression does not name a real number, say so. 18, 8 to the 1/3 power is the cube root of 8 to the 1st power, which is going to be 2. Number 20, 100 to the 1/2 power is the square root of 100, which is 10. 22, -625 to the 1/4 power would be the 4th root of -625, but that's an even root, and that's not possible. We come out, there's no number multiplied by itself 4 times. It's going to give you a negative value, so not a real number. Number 24, you have -343 to the 1/3 power. That's the cube root of -343, and that does work. It's since it's an odd root, and if we take 343, we can see it's, whoops, it's going to be -7. Number 26, it's 16 to the 3/4 power, so it's the 4th root of 16 cubed. The 4th root of 16 is 2. 2 cubed is 8. Number 28, 81 to the 3/4 power. It's the 4th root of 81 cubed. 81 to the 4th root of 81. Let's see if it works this time. Is 3. So that's going to be 3 to the 3rd power, which is 3 times 3 times 3, which is 27. Number 30, -1000 to the 2/3 power. So that's the cube root of -1000, which is possible because the root is odd, squared. So the number times itself 3 times, it makes -1000, is -10, and we square that, we get 100. And 32, 25 to the 3/2 power is the square root of 25 taken to the third power, which is 5 to the third power. And 5 to the third power is 125. You can use your calculator to verify that. 34, 243 to the 4/5 power. That's the 5th root of 243 taken to the 4th power. So 243, the 5th root of that would be 3. So that's 3 to the 4th power, and 3 to the 4th power should be, whoops, 81. That concludes the evens. Be sure you check the back of the book for the answers to the odds.